more maintainable and testable code. The software design patterns, things like inversion of control, are one of these advanced basics. And then unit testing or writing code that's maintainable and testable is another one of those skills that you sort of pick up after spending a lot of time writing software, or it's the kind of things you have to learn to really go to the next level as a developer. So, again, law of 2 feet, I guess that still applies. If you don't feel like you're getting anything out of this, I won't take offense if you want to walk out the door or go home and be with your family or watch, let's see, Thursday night, what's on Thursday night? Impractical Jokers. It's a great show. Anybody watch that? It's awesome. It's the funniest show on TV, I think. But, if you're not getting anything out of this, go ahead and leave, and we'll make fun of you after you get on this. So, let's go ahead and get started. As Matt said, I'm Adam Barney. I'm a Microsoft Visual... The logo's not there, that's weird. None of the graphics are there. It must be the internet. Wow. No, I'm connected, that's weird. Huh, I'm going to reload it real quick. This graphics will kind of play a part in this later. It's not important for you to see the NBC logo or anything like that, but diagrams are nice. Let's try this again. That graphic was there, though. All right, whatever. There we go. All right, so Microsoft MVP in C#. About 6 months ago, 8 months ago, I started my own company. It's official now. I have embroidered shirts, backpack. There's no going back now. Once it's in stitching, it's permanent. I actually put that on Facebook, and one of my friends says, well, I got my company's logo tattooed on me, so I'm not sure if I'm willing to go that far, but most of the involved in the .NET community. Like you said, I run the Lincoln.NET Users Group and the Nebraska Code Camp, which, wow, I suppose I can announce the Nebraska Code Camp version 4 is going to be on March 28th and 29th, Friday and Saturday, right around that time. So we'll hopefully have some information on the site coming up pretty soon, and I'll make sure to pass on the relevant information through Matt so you guys can be amongst the first to sign up. This thing here is like a financial parent that we set up to be over these two groups, and don't have anything to announce. I put that on there a little bit prematurely. I have a lot of cool things that we're working on to kind of benefit the community of developers, but for now it's just a free logo. And you can find me basically anywhere if you search for me. Although Google Images, I'm not the first. There's some lawyer named Adam Barney, and there was a kid named Adam on the Barney Show when it aired. And his photo actually shows up above mine. But if you want to email me, that's really the best way that you can get in touch with me. If you have any questions from tonight that I didn't have a chance to answer, please feel free to send me an email, and I will do my best to answer it. I have a blog on adambarton.com that I promised to update about 30 different times, and really all it comes down to is just, I'm going to be speaking here. I spoke here are the slides. I'm going to be speaking here. I spoke there, here are the slides. I really am going to start doing it though. This time I mean it. And I've said that for the last 2 months since I've been doing this stuff. BarneyConsulting.net is the website of my company, and I do have some availability, so if you or your company have some sort of smaller project type work that you're looking to farm out to somebody, then by all means let me know. Drop me an email or visit the site to kind of find out what sort of things I can do. And yeah, I'd love to work with you. So LinkedIn.com or I'm on Twitter, but I don't tweet much. So yeah, you can find me if you look for me. All right, so here's kind of an overview of where we're going. we're going to talk about, we're going to set the stage with asking the question, what is inversion of control? That's going to kind of lead us to a little bit of confusion about what it really is, and some confusion amongst terms, and so we're going to kind of cover that over here. We're going to do some demos, and we'll kind of wrap it all up and be done with the night. So, what is inversion of control? It's kind of a broad topic, and there's this whole idea of inversion of control, the other terms that are used to describe it, brings up one of several terms, or three terms in particular. Three's a magic number, by the way. Nobody want to count how many times I say there are three types of whatever. Dependency inversion is one of them. The actual phrase inversion of control, and dependency injection. And for the most part, people think those are all sort of the same thing. And in ways they are, but there are some very distinct differences and important differences between those three things, and we'll kind of go through and talk about what those differences are and why they matter, and yeah, hopefully you'll walk out with a better understanding. And that's what I just said a little bit ago. So that's redundancy. Well, although don't repeat yourself, that's a different principle that you want to have in your advanced basics toolkit. So let's go ahead and get started with demystifying inversion of control. So I said there are three different terms, right? There's the dependency inversion principle, and that's a principle. Inversion of control is a pattern that helps us kind of describe how we do the principle, and dependency injection is an actual implementation of the inversion of control pattern. So we'll go through each one of those step by step. We'll start off with the principle, which has a dependency inversion principle, but let's talk about for a moment what we're talking about when we use the word dependency. It's basically anything, when you look through your code, or this code here in particular, if we have a reference to a static class, or a concrete class, that's a dependency. So any concrete class, that would qualify. Any frameworks that you happen to use, third-party libraries, if you access your database in your code, those are all dependencies that your code has upon those things. Any system resources like datetime.now or datetime in general, that's a dependency. If you read some sort of configuration, and if you're doing it directly from your web config file, or using the system interfaces for fetching that stuff, you're taking a dependency on the configuration. And not all dependencies are bad. You know, you have a dependency on the .NET framework when you're writing C#. And that's the kind of dependency that you kind of knew you were getting into when you started, and it's kind of hard to abstract away the actual framework. Although, they're kind of trying. There's different ways people are trying to do that, but not all are bad. The ones that are bad, the kind of dependencies that are bad are the ones that, if they're missing or broken, they break your code too. All right, so if class B had a bug in it, or if class B didn't compile, even, you know, our code's going to be broken. Or there's a, you know, let's say that we were told that class B, that's being worked on, but it's not quite ready yet. Well, if it's missing, then our code here isn't going to work. All right, so it's bad if it breaks our code when it's broken. So here's the dependency inversion principle as set forth by Uncle Bob Martin. It states that high-level modules should not depend on low-level modules. Both should depend upon abstractions. And abstractions should not depend on details, but the details should depend on the abstractions. To put this in perspective, let's look at some of the examples that he had in his paper. It was originally published as a white paper, and in it he kind of proposed this sample application. We have a copy program, and we want to read keystrokes from the keyboard and pass those keystrokes out to a printer so that we can print it. All right, so as is, if we are never, ever, ever going to read anything but the keyboard, and we're never, ever, ever going to output anything to anything other than the printer, then as diagrammed here, this is fine. This is just saying the copy program is taking a dependency on the keyboard reader. It's actually implementing, it's new enough the keyboard reader class, and it is completely married to the keyboard reader. The problem where this breaks down is if the boss says, hey, I love the way that I can get my keystrokes to show up on a printer. Wouldn't it be cool if we could also maybe take my keystrokes and put them into a file? Or maybe let's see if we can read some keystroke or read some text from a file and put it out to the printer or put it out to a file. As soon as we start doing this, and this is only a couple of examples, you could think about fetching data from a web page or sending it over FTP or emailing keystrokes or whatever. When you have this, when you have your high-level concepts, your high-level programs directly relying on the low-level implementations, this turns into a big switch statement, right? What do they say? Every time you use a switch statement, God kills a kitten, or something like that. Switch statements are bad for so many different ways that I'm not going to get into tonight, but this becomes very unmaintainable. If we have 50 readers and 50 writers, then that's just a bunch of spaghetti code in our copy program. And really, the copy program, all it cares about is getting data from one place and putting it somewhere else. So when we flip it on its head, and we follow the principle, now we make our, instead of high-level things relying on low-level, we make them both rely on an abstraction. So we abstract away this idea of reading text, and we abstract away the idea of writing text, and so we have these interfaces, these abstractions in between. And in the copy program, this might be the only part that's in the copy program here, right? Or the only thing that we care about as the developers of the copy program. We just know that we want data from our reader, and we want to send data to our writer. It's up to everybody else now who are writing these plugins to implement the reader and the writer classes as necessary, and then we can, then it becomes a lot more maintainable because we don't have a switch statement, or we don't necessarily have a switch statement. And copy program doesn't care about the individual details. These are all their own individual modules. So here's another example. If in our homes we didn't have this interface called an electrical outlet, we might have to care about where our power came from. Right? If we bring a lamp home from the Home Depot, and at the end of it are just two wires, and maybe we have a power grid that has run a wire up to our house, and this laying out there in the back. Maybe we have a gas-powered generator that has a different interface that it delivers the power through, and it might be a different voltage or different current coming through it. Maybe we have Lance Armstrong out in the shed pedaling and power. You guys can see that ESPN commercial. I love this. I love that Sports Center commercial. So maybe Lance Armstrong is powering our home. The point is, we shouldn't have to care. Our lamp just needs power. It needs a certain voltage and a certain amperage, and that's what's provided by the outlet. It's an abstraction. This is an abstraction for consuming power. And both the power grid or Lance Armstrong or the gas-powered generator, it relies upon that abstraction, and so do our low-level concepts like lamps and refrigerators and laptop chargers, things like that. So this is the abstract implementation, or the abstraction that we're kind of referring to in the dependency inversion principle. Okay, so that's pretty abstract. It's not, it doesn't tell us how to sit down on the computer and write code. I mean, we have to diagram, we show a picture of an electrical outlet. How do we actually do that? Well, when we think about trying to put a principle into practice, we look at patterns. Patterns are kind of guidelines. Principles are sort of, it's good to do this. Principles tell us what things we should like doing and what things we should stay away from. The patterns actually kind of tell us how to take that guidance of what's good and apply it to our problem. So there are three ways that you can use inversion control. And inversion control is the pattern that we're talking about here. We can invert our interfaces. I'll have diagrams for all these here in a second. We can invert the flow of our programming. And then we can also do creation inversion, which is, when we say that we're inverting control, we're taking the scenario, the kind of the normal scenario where, geez, I just talked myself in the corner. I'm not sure exactly I'm not sure where I was going with that. Forgive me. We're inverting things, and that would make a lot more sense when I get to these things. So let's just go here. This is kind of like our the copy program, and the principle, the dependency inversion principle, still work here. These triangles here are the abstractions, or interfaces. Okay, so both the high level and the low level concerns are depending on interfaces, but this is not a good model. Right? So in this case here, if this is the way that Visual Studio worked, and this is the way that maybe you got plugins for its rich ecosystem, then this means that Visual Studio would have to know about every single one of these interfaces. If it wanted to use ReSharper, it was going to have to implement the ReSharper interface. If it wanted to use the Web Essentials extension for Visual Studio, it would have to implement that interface. That's no good, right? There still has spaghetti code up here. And every single time that Visual Studio wants to support a new plugin, we have to install a Service Pack 6 release came in for Professional Edition, and it's going to take 2 hours to download the 8 gig patch, right? It's a bad model. So when we invert that, we're inverting the control here of who controls the interface, who controls the definition of the interface. In the previous one, plugins control the definition of the interface. If we invert that, now Visual Studio is is in control of defining the interface. So now we have one interface, and all of our plugins have to implement that interface if they want to be a part of the Visual Studio environment. So now from Visual Studio's standpoint, it doesn't have to worry about these plugins. It doesn't have to worry about changing or releasing patches to support different plugins. It just exposes the interface, and that lets the plugins do the work of implementation. All right, flow inversion. How many of you have written this program before when you first got started? All right, it's just your simple console app where step 1, print something out to the screen. Step 2, read a numbering from the user. Step 3, print out another line from the screen. Step 4, wait for the user to enter some more information and then read it from them. Step 5, do a calculation. Step 6, output the result to the screen. This is a very linear flow here, and our application, our console application, is in complete control over how the user flows through our application. If we invert that, we get something like the event-driven model. where the application, what it does is it creates the screen and gives it to the user and says, okay, now you're in control. I'm just going to wait here. You go ahead and do whatever you want to. If you want to enter the second number first, be a real rebel, you can do that. That's okay. We just don't care. So you have your two numbers in there, and the user at this point is in complete control over the flow of the application, not the program itself. Now when we click the button, we say, all right, now I'm going to hand control back to you, application, so you can go respond to the event, do a little bit of logic, and we're just going to set the text property of our result text box right there, and then we return control back to the user. And we're just sitting there waiting for the user to tell us what to do and to drive us, and we're letting the user control the flow of the application. Okay, so that's flow inversion. Creation inversion is the one that's the most exciting. It's the one that we think of most when we think about inversion of control, or IOC containers, or dependency inversion. So normally, higher level classes are responsible for creating its dependencies. So here's our class A. We have a dependency on class B, and in the constructor of class A, we create our dependency. Now the S in solid, by the way, for the solid principles, is a single responsibility principle, which says that a class should only have one reason for changing. It should only do one thing. This class right here actually does two things, right? It does something, and then it also creates its dependencies. Okay, so these are two different things. It has two responsibilities, two reasons to change. If it has to change the way it does something, that's a reason for it to change. And if class B suddenly changes the way it needs to be created, then our class A needs to change the way that it creates its dependency. Okay, so this is kind of the, if you're just learning programming, this is the way you're going to think about doing it. But if we invert that, what we do is we give control to our caller. We give control to the outside world. Give it control for creating or over creating our dependencies and giving them to us. So in this example here, here's our class A we create our dependency and we just hand it to our class A. So class A down here now is not actually creating the dependency, it's just being handed to, it's having it handed to it. So its responsibilities now are doing something, and that's it. If the way that we create class B changes, then we don't care. We don't have to change our code. If we're the owners of class A, we don't have to change our code if class B gets constructed differently all of a sudden. Right? The application is now in charge of creating class B. So this is going to have to change if class B suddenly requires an argument in the constructor or something like that. But this is the inverted way of creation inversion, or of creation. We're giving control of someone outside to create our dependencies. All right, there are three types of creation inversion. There's a factory pattern where in our constructor here we are delegating to this factory the task of creating our dependency. So we're still not tied to the way that class B is constructed. We're delegating that to someone else. Service locator is actually very similar. It tends to be a bit more generic in the way that they're called. And here we're not really telling it to go create an instance of class B, although it might. That might be the way that it finds class B, but a service locator basically just is responsible for going out and finding an instance of class B. Maybe we created one somewhere else and it stuck it into a cache or something like that. Service locators are more generic in that way, but they essentially do the same thing. We're still delegating the responsibility of finding and getting the class B to someone else. And then there's dependency injection, which is where we actually are passing the class, our dependency, to the class itself, which is what we were shown in the previous slide. So, dependency injection, that's the one that most people think of when we are thinking about IOC containers. And when the really smart people say, oh, are you using conversion and control in your application? This is usually what they're talking about. Yes?
I have a question on that slide. Just your thoughts, really. It seems to me like the factory and service locator patterns are, you're taking a dependency on the factory or the service locator. Is that just a compromise that we're willing to make?
Sort of, yeah, you're right, it is still a dependency. And the thing that I guess I didn't actually state out loud is that, so dependency inversion and control, dependency injection are not the same thing. They're not completely orthogonal, but they do address different things. And so, I mean, we're inverting control here, but yes, we are taking a dependency now on a service locator or on a factory. And here, it's kind of an implied dependency, but we're still taking a dependency on somebody else giving us our class. You're still depending on that happening. But dependency inversion is talking about more about caring about the interfaces rather than the details. Inversion of control is more about not doing a second thing in our class.
Okay, that makes sense. Thanks.
And then dependency injection is sort of the thing that we really use most often. It's kind of at the core of these IOC containers, which we'll talk about in a little bit. So we've gone over the concepts. When it really comes down to it, and we're going to sit down and actually write some code that's going to help us do the good things that dependency inversion tells us to do, and take the control of creating our dependencies away from our classes. This is the way that we end up doing it. We do it through dependency injection. And there are 3 flavors of dependency injection. There's constructor injection, which is what we've been looking at in the previous slides, where we're actually just passing our dependency right in there. There's setter injection, which is where, here's our class here, we still have an empty constructor, we still have our dependency here on class B, but our outside creator is also creating our dependency, and then just setting the property on our class A to our dependency. And then the one that's not used as often, and I really should update this slide because there's a better way of thinking of this interface, and I'll try to show it in the demo here. But basically, what this is we have our class A, which implements a interface called I need a dependency. Here's what we have to name it that. You can name it anything you want to, but that interface exposes a method through which a dependency can be injected into your class. Okay, so we have this method called inject dependency. We implement that here in our class A. The dependency is passed in, and we keep a copy of it for our future use. So this is pretty much essentially the same thing as constructor injection, but we're not injecting it through the constructor. We're injecting it through a method that we've promised to implement through that interface. Okay, let's see this in action. Let's do some demos. I'm going to do a time check. I'm always shocked at how late it is whenever I check the time at this point. Okay, about halfway through. That's actually not too bad. Okay, so first demo is just a very simple refactoring of a couple of classes. So here is how's the font size? It's a big projection, so Good all around? Yeah? All right. Here is the simple demo that we're going to be working with. We have a order processor that's going to process some orders, surprisingly enough. And what our order processor does is it's going to ship the order to the customer. So we have a shipping service that we need to use to ship things out, and the way we started this project is the boss came down and said, we need to ship orders through UPS. And that's all we need to do. We just need to ship the order through UPS. So we just wrote a UPS shipping service here. Although this is kind of a spoiler alert, if that's really all we were doing, we wouldn't actually have to have a key and a name to identify it. But it has a method called ship order. It takes the order and we do shipping stuff and send it off to, we go create a tracking number and schedule a pickup with UPS. All right, and order class is just very basic. It's an ID, an order number, and a string to indicate the shipping method that we want. Which right now is only UPS. So, right now, as is, what is wrong with this code? If the boss says we will only we'll never need another shipping service, and we don't care about unit testing or anything like that, what's wrong with this code? Nothing, really. I mean, if that really is the requirements, you'll never have to use different shipping things, and we don't care about testing. There's nothing wrong with this. This is the simplest way to do it, right? But it's never like that, right? The boss is going to go to a conference, and he's going to come back, and he's going to say, my friend Joe just told me that they switched to FedEx, and they should save 30% on their orders. So we should maybe think about using supporting FedEx too, or maybe we spun up a QA department, and QA wanted to start testing our application, and they went through and they took, they created 10,000 fake orders and ran them through to test our order processor, and as a result, we purchased 10,000, or we placed 10,000 orders with UPS and got prepaid shipping labels from UPS as part of the QA process. Whoops. I sort of know this from personal experience. There was a former employer of mine who, when I left, the person who came back and backfilled my position has a deep personal hatred of me for the code that I left behind. I learned all this stuff almost as my apology to him. Now, granted, there was a lot of that, ignorant boss type pressure to do things the wrong way, but I caved and I didn't do it the right way, and yeah, it's a mess. There was code that was just spaghetti code all over the place, and I knew someone who was there, or who's still there, and when I was getting ready for this talk, I was thinking, I want to use that as my starting point and refactor that and show how bad that code was. And I asked the guy to search the code base for the word interface. This thing had probably 200,000 lines of code. The word interface in a whole solution search did not show up once. So, yeah, pretty bad. So the way that we did, if we had to test the code, even though we were bugging it, that's how you test, right? You go in there and you comment out the parts that are going to cost you. Or better yet, it would be in here, right? So maybe that was actually, do shipping stuff. Actually making a call on that. And no, we want to just comment that out because we don't really want to do the shipping stuff because it's going to cost us a lot of money. All right, so that's obviously not the way to go. So there is lots of things wrong with this code, and we're going to go through and apply some of the things that we've learned here over the last 45 minutes. All right, so, one other scenario where this would work is if we were told to write this code now, they said, we want you to write the order processor, and you're going to have to interface with the UPS service. You have to have the code done by Friday. And I go, okay, well, just go ahead and give me the UPS shipping service code. Oh, that's not done yet. That's not on the schedule until next month. Well, if I don't have the code for the UPS shipping service, it's missing, and I can't do anything here. If I wanted to make my order processor class not depend on the UPS shipping service, I need to depend on abstraction instead, so that even though that service might not be there, I can still write my code and it won't break. So let's start off with that. Let's go ahead and extract some interfaces here so that our high-level modules will not depend on low-level modules. They'll depend on abstractions instead, which is the dependency inversion principle. And here comes some magic if you have not used ReSharper, one of the plugins for Visual Studio. How many of you use ReSharper? Really? Oh man, all right. It is hands down the most bang for your buck in developer productivity. Hopefully I'll show you a few little magic tricks that you can do with this. There's this huge wealth of things you can do with it, but learning one keystroke, Alt, Enter, will save you just untold hours a week. Amazing. All right. I want to extract an interface for the, we're going to start with the shipping service. And this is new in Visual Studio 2013. I haven't quite wrapped my head around this, so yeah. Anyway, sorry, that's neither here nor there. UPS shipping service. We're going to go Control-Shift-R, which is the other cool keyboard shortcut you want with ReSharper, and we're going to do extract interface. And let's not tie ourselves to UPS. We're going to just name our new interface iShipping service. And we'll go ahead and just include all these parts in our concrete class. We'll just include those in our interface. Okay? So what it's done here is it's extracting an interface. So now we have our iShipping service interface. And here's the UPS shipping service which implements it. All right. Let's come up here and do the same thing with the order processor. And we're going to change, instead of relying upon the concrete implementation, we're going to rely on the abstraction. Although you will notice though that we are still tied here. Right? So this is better marginally than what we had before. But we're still creating our own dependencies. Right? So we're still doing two things in our order processor class. So next step is to invert the control and give the control of creating our dependencies to someone else. We're going to delegate that, in this case, to a factory. And we're going to use another amazing productivity tool for developers. ReSharper is good, but it's not nearly as good. It's not nearly as good as using the Windows computer. Now I can't escape. I can't get out. It's happening. What in the world? Come on here. All right, all of you Mac naysayers, you win. All right, here we go. All right. Ah! Man, I learn something new every time I present with Amada users. This is amazing. What? All right. Got a backup. I'm good. This is where good demos come to die. Sorry. Not appropriate. Okay, I'm going here and here, there, and here. So the other development tool that's really great for productivity is the notepad with your code already written. This is amazing. All right, so we're going to create a factory, and I'll put that down. Go down here. So there's our factory. We have a factory class which has two methods, both of them static: create shipping service and create order processor. And so now we've put the logic for creating our UPS shipping service and for creating our order processor in there. So now we can come back up to our order processor, and instead of doing that up ourselves, we can just go factory dot create shipping service, and then up here in our main method here, we can also do factory dot create order processor. Okay. So we're getting there. Okay, now order processor does not violate the single responsibility principle. It's only doing one thing. It's only processing orders. It's delegating the process of creating the shipping service to our factory. Still not great here. It's like Matt said, we have a dependency on our factory now. If we wanted to do a unit test on our order processor, this isn't just the most wonderful thing to do. I mean, we could, if we made our methods in the factory there, instead of being just, things like that, we could do something like a public static func that returned an I order process or order processor. We could do that. Or we do, create or create order func. And that would equal, say, a lambda here that would return just new order processor. There we go. All right, that makes it a little bit more testable because now in our test project, we can just set the create order func to one that is maybe creates a new fake order processor. Something that we're going to use for mocking and testing. All right, so this becomes a bit more testable, but it's still not ideal. This is still a dependency that we're taking there. So let's all right, again, so we're in a much better place here, but let's say at this point now, this is the time our boss walks in and says, all right, yep, the Joe was not kidding, we can save 30% on shipping if we use FedEx. But sometimes UPS is cheaper, so let's go ahead and support both. Come back to our great development tool here, and we're going to take out our FedEx shipping service. We'll just stick that in here next to the UPS one. All right, and you see here that FedEx shipping service implements iShipping service, so we're taking the same, we're implementing the same abstraction. And so now what we want to do is in our order service, our order processor, we want this to be an IEnumerable of iShipping service. Because we need to support multiple. So we're going to call that our shipping services. And we're just going to go change this name. Boy, it's kind of annoying, isn't it, that when we have to, oops, well, I'll come back to that one. Whenever I want to change the way that we created dependencies. We've got to go down here to my factory and change this. That's important, but I don't know anything right now. My movable shipping service. And create shipping services. And we're just going to return now new list. Shipping service, which contains our UPS shipping service and our FedEx shipping service. Right? Okay. Flip the screen. Okay, and then when we actually do the ship order or process order, we just need to come in here and select or grab the matching shipping service. So we want to grab the one that has the shipping key that equals the order shipping method key. Okay, so once we grab our shipping service that our order specifies, we'll call shipping or ship order and pass it to the order. Okay, so now we have support. We have kind of our little plug-in model here. We're relying on an interface rather than a concrete implementation is paid off here, because now we are able to have kind of a plug-in type model. We're controlling the interface iShipping service, and we can now bring in any shipping service that implements that abstraction. Okay, so I kind of alluded to this, that when I changed the way that we did this, I had to go change the factory method. Right, now, you know, if we wanted to do, I don't know, well, here, this is what we want to do. In our order processor, we want to take we're gonna brain dump. Sorry, I'm dumping the file right now. Crash log is right in the disk. All right, we're still, every time we want to change the way that one of our classes is created, we still have to go change the factory method, and we're not going to fix that quite yet. But we also want to, you know, this still, like I said, is not terribly testable because of the way that the factory works. So what we really want to do is actually pass in this list to the order processor. So we want to take in INA packaging service, all shipping services, and then watch this. Alt enter. Hey, see that even I can tell that was very impressed with you. That wasn't even up there. I can write my constructor any way I want to, and then I can just, you know, mouse over to any of the parameters and go alt enter, and it will create the variable and set it within the constructor. It's pretty cool. Okay, so now we're going to have a compile error here because our factory methods needs to change now because now the way we create order processors has changed. So now in here we need to do, we've got to call create shipping services to create the shipping services and pass it to the order processor. Okay, so now this all works again, and our our order processor is now completely tested, right? Because now we can create our fake shipping services and just pass them into the order processor, and we can test our process order logic without fear of using a real shipping service that is going to cost the company hundreds of thousands of dollars. Ask me how I know. So this is good. It's testable now, which means it's going to be more maintainable. It's pretty good all around, except again for the fact that the factory method is there, and every time one of our class constructor signatures change, we have to go change the factory. So let's create, wouldn't it be nice if we could make this more generic? Instead of actually, creating methods that, are named, create shipping services, and having one of those methods for every single thing that we're going to create, it'd be nice if we could make this generic. And we can. I wouldn't have said it if I wasn't done following through with that. And this is kind of a spoiler, another spoiler alert. The class is going to be called Injector. I don't know why. This sounds powerful. All right, we have this class called Injector, and not going to dig into the ugly guts of reflection in .NET. It's not that bad, but kind of beyond the scope. I'll just go through real quick and kind of tell you what each of these methods is kind of doing. We basically have just a couple of public methods. The main functionality of this thing is to resolve a type, to create a type for us, like the factory did, but in a generic way. So we want to be able to say, hey, Injector, hand me an instance of type T, which I'm going to pass in. So I need an instance of I order processor. Okay, this is going to call internally then this resolve method. And we have this list of providers right up here. This is just a dictionary. It's a map between a type and a function that returns an object. So you can think of this as being, when we ask for this type, here's the function that we call to create that type. So when we resolve, we're going to look through the list of providers and see if we have an entry in our dictionary for how to create an instance of the type that we're passed. And if we find it, we're just going to call that function. We're going to call the function and return that type, the returning type object there. And then up here you can see we're casting back to T. Okay? If we don't find an entry in that dictionary, we're going to call resolve by type. This is where the reflection comes in. We're going to use reflection to get the list of constructors from the type. And we have, this is a pretty basic class here. We have a restriction that it can only have a single constructor or no constructors at all. If we don't have a constructor, we're going to call activator.createInstance, which is basically just the same as doing new whatever with the default constructor. This will just call the default constructor on our type, and then pass back the instance that creates. If we do have a constructor, only one, we're going to get a list of the arguments, we're going to get a list of the parameters. We're going to call this constructor.getParameters, which is going to come out with an array or a list of, it's an array of parameter info. It's going to list all the parameters for that constructor. And for each one of those, we're going to call resolve, our resolve method up here. We're going to call resolve on the type of that parameter. Okay, so that's going to return an argument, or it's going to return an instance of that class, which we are going to bundle up into an array of arguments, and then pass to the constructor by calling the invoke method on the constructor. Simple, huh? I will admit I copied this from the internet. More or less. I modified it. I understood what I was doing, so it's cool. Use with permission, I'm sure. All right, so this also has the nice benefit of being recursive, right? So if the parameter here, we call the resolve on that parameter, it's going to go up here, and it's going to go see if we have a provider for that, and if so, we're going to create it. If not, we're going to resolve by type, and we're going to go try to figure out how to create that object and pass it to, back into the original call. So that's kind of cool. And then the other public methods are kind of the way that we configure that dictionary, the way we configure that list of providers. We have two ways that we can do it. We can basically use this map, where we're just saying, when we're going to register the type of implementation for a given type that's requested. So we're going to map the requested type T to an implementation T impl. Okay, and we have the constraint where T impl must implement T, which makes sense. So in this case, it would be like we might map iOrder processor to order processor. If we call that, we're going to add to our providers. We're going to create a mapping for the type of T. So the value, which is the func of type object, for the index of type T is this lambda function, which just calls resolve by type. So it just calls this. Go create that T impl. Do your best to go figure out how to create that. Now I've set this up for success, that it's going to work. I mean, if we had to support every single type in the framework, this is going to break down pretty quickly. But for a simple demo, this is going to suffice. The other way we can do it is we have this register of type T, and we're going to pass it an instance. So in this case, we're just saying, if you're being asked for this type, don't try to resolve it or figure it out. Just here's the thing I want you to hand back to the person who's asking for it. Okay, so there's an Apple store in Omaha, right? I'm gonna go complain.
Nobody here knows where it is.
What?
Nobody here knows where it is.
You know, I will say this about Apple, that I didn't know this soon enough. My daughter cracked her iPod about 6 months or 3 months after she got it, and broke and we bought her a new one. And then somebody else, like a year later, said, oh yeah, my daughter cracked her iPod too. We went to the Apple store, they just gave her a new one. And I didn't have a receipt, it just said, they got a cracked iPod. Oh, here you go, here's a new one. And we the first time we paid to have the screen replaced for $150, and we bought her a new one. And the Apple store just, here's a new one. And then if it happens a second time, it's $99 for me. Who knew? All right, sorry, that was off topic. All right, so now we're going to use our injector, right? We want to actually make use of that. So we're going to create an instance of our injector called IOC, and we're going to register a few of our types. We're going to register we're going to create a list of, all right, hold on. Here's our list of shipping services. Okay, that's basically pull it out of our factory. So right here in line, we are creating a list of our shipping services, UPS shipping service and FedEx shipping service. So that's an instance of a list of iShipping service, and we are going to say to the IOC container, or sorry, I shouldn't have said IOC container, it's a spoiler. We're going to say to this injector, register this type. When somebody asks for iMovable iShipping service, give them this instance. Okay? Next line, we're saying that we want to kind of create this mapping. We want to register iOrder processor and order processor. So when somebody asks for an iOrder processor, we want you to give them an order processor. And then we're going to call IOC.resolve for the iOrder processor. So now we're saying to the injector, give me an instance of iOrder processor. So when this happens, you're going to have our injector here. We are calling resolve iOrder processor. So we come down here, we're going to cast the result of resolve of type order processor, or iOrder processor. We're going to cast that to iOrder processor. In this method here, we're going to go look for our provider's dictionary. Now we will have that in there because we called this register method earlier. It said when somebody asks you for type P, call this. Call resolve by type of type implementation, which in this case is order processor. So when we call resolve of type T, we're going to find the provider and we're going to return the provider, the call of that provider. So that's going to call this, right? Because that's what we set up down here. It's going to look for the constructors. It's going to find one, right? It takes that list of IEnumerable iShipping service. So it's not going to equal no. We're going to grab the parameters, which is the list of shipping services, and we're going to call resolve on that type. Well, we've also registered that instance of the list of shipping services as IEnumerable iShipping service. So we have a provider for that too. We'll call that, we'll just pass that instance back into this argument, and then we'll call the constructor on order processor, passing in that shipping service array. Clear as mud, right? Let's go ahead and set some breakpoints just to prove that I'm not completely full of it. I am using a Mac, so I can understand why you might be skeptical. All right, let's just go ahead and set them on all these things here. All right, so the first thing that we're doing, I should have set up here too. We're actually right here. Oh, hey, look at that, it's highlighted because it wasn't down there in that method. That's cool. That's a new one. Okay, so we're down here, and we are registering this instance, which you can see is just right now, it's our UPS shipping service and our FedEx shipping service. T is type generic IEnumerable of iShipping service. Okay, so that's what we're doing then. We're setting, now our providers is going to have one provider in there, which is a function that returns an object, and in this case it's the IEnumerable of iShipping service. Let's keep going. Now we're registering the iOrder processor and order processor. See, so there's iOrder processor and order processor. And to do that, we're just setting the provider to be resolved by type. Keep going, and now we're at the point where we're trying to resolve our iOrder processor. We'll step into that. Okay, and we're going to try to get our provider out of that dictionary. We're in here, so we succeeded. So we have a provider here. And so now we're just going to call our provider, which is to be resolved by type of type order processor. Okay, so we have a constructor, a single constructor. It takes a collection of iShipping services. So we're going to call the resolve on that, which means now we're trying to resolve the collection. We found the provider, we call the provider, which returns the instance, which returns that to that. We get the arguments here now of our shipping services. We call the constructor of the order processor, passing these shipping services to it. And we keep going here. Now we're processing the order. We have our shipping services, UPS and FedEx. We have our order that has the shipping key. We're going to find the appropriate one and call the ship order. So it's this one here. And there we go, there's our order, we call that. And it all works. So, as if you hadn't guessed it, injector here is a very simple inversion of control container. And an inversion of control container is a kind of at the center of what most people think of as using an IOC in their projects. So, geez, look at the time now. Good grief. I will never finish this thing on time in my life. Hey, that still works at least. All right, so let's go through this part real quick then. All right, so in real life, you don't have to do that by hand like we just did, because it's annoying and it's not very robust. The thing that we implemented right there, that's very simple, and it's going to break down under even moderately complex object drafts. Fortunately for us, IOC containers, and there are many of them, provide all that functionality that we just showed there, plus a whole bunch more, like support for multiple constructors, which is, tends to be a useful thing. It supports constructor injection. A lot of them will support the interface injection as well. We also in there did, if you notice, we had to go through and configure our container, right? We had to go through and register every single type with the container if we were hoping to use it. Unless it was a class that we didn't care about having an interface on it, it was just a class that had no parameters in the constructor, then we can just let it, make its best guess, and call the activator.get instance. But we still have to go through and register the types that we care about. A lot of the IOC containers now will support scanning. They'll go through and they'll scan your assembly and look for objects that implement interfaces, and it'll apply some conventions. So for instance, it will say, oh, I have something called order processor, which implements an interface called I-order processor. I'm going to make the assumption that when somebody asks for I-order processor, they really want this an instance of order processor. So that's a naming thing. I mean, if it was like you had like I-order processor, and then the implementation was my super duper order processor, it wouldn't make that leap less intelligent. I mean, they're so powerful, and there's so many different configuration things. But out of the box, it does everything that we just did there, and some, very easily. Here's a bunch of them that you can look at. I don't really have any ones I'm going to point to that are better than the other ones. The tests have kind of said, as I'm pointing now at ones, speed tests have shown that AutoFac is pretty darn fast, and Inject is not so fast. And Structure Map is the first one I use, so I kind of like that one too. It's the one I kind of kept my teeth on, and I used that one first because it was the first one I think that I knew of at least that did the scanning. Because the first one I used it, I had this project that had just hundreds of types that I'd have to register, and that seemed like a lot of work. It was nicer just to say, hey, Structure Map, scan my assembly, and I'm going to trust you to make some good judgment calls. In reality, you really want to test that. And I'm not suggesting you just kind of give complete control over to a library and hope that it does the best for you. But yeah, any of those things are gonna suit your needs, I'm sure. AutoFac is the one I use most often now. So in like 3 minutes, I'm not really going to have time to do this, so I'm just going to show you real quick here. I'm going to do the Julia Child thing and go, oh look, it's a demo with MDC using an IOC container. And actually this one I did use Structure Map. What do I got? 4 minutes, no problem. We can go like a couple minutes late, yeah? I mean like 5 minutes? No, you're shaking your head. Okay, all right. I won't be long-winded on this one, I promise. All right. so you start an MVC project, which is really the way you want to be doing web for the most part. We can discuss that later if you want, but let's bring up the package manage console. And the way you do this is you just go install package. Everyone use NuGet? Okay, good. If you don't use NuGet, that's even better than ReSharper, and maybe even better than the Notepad copy complete code thing. There's so many different libraries you can suck in using NuGet. Let's see, right, structure map. So I'm hitting tab here, and it kind of gives me a list of the ones that are compatible. So there's structure map that MVC4, which is, I think is the one that I've already added to this project. So you do that, and then if you hit enter, it would pull down the structure map libraries, it would pull down any dependencies that structure map has, get it all wired up in your project, and really start you off on, on the right foot. So let's see what it would do if we actually made it do it live. It's going to do a few things. It's going to add this dependency resolution folder, and in case you don't know, MVC, starting with version 3, has made dependency injection kind of a first-class citizen. It actually, when ASP.NET says I need a controller, it's going to use a default dependency injection or IOC container to resolve that controller and its dependencies. Now the default one is really stupid. All it does is call activator.getInstance. So if you don't have a default constructor, it's going to fail. But the point of that, though, is that it has this everything that it does, it goes through a dependency resolution step, which means that we can just swap in our own dependency injection framework or IOC container. We can inject that into the pipeline and control it. So, for instance, here is the structure map dependency resolver. And what we've done here, so I'm not going to go into the details here, but this is pretty much just, this one here is around scoping, so you can have object lifetimes only for like an HTTP request lifetime. I didn't mean to show that one. What I meant to show was this structure map MVC class that is in the app start directory. This will get called the first time your app is started up. And what we're doing here is we're initializing an IOC container. And then here's this dependency resolver. You can see there that's defined in system.web, the MVC, that dependency resolver. And so this is the thing that everything is passed through for controller resolution. And we're just going to say set the resolver, say use this one instead. Don't use your dumb activator.getInstance. Use this structure map dependency resolver, which is down here. Okay, and we create that by passing our container. And the container is created through this initialize method, which is in here. And this is where we do our configuration of all of our classes. This is where we would set the say that if you are asked for iOrder processor, give them order processor. But instead, we're going to scan the calling assembly with default conventions, which means if you find an interface that starts with the letter I, and you remove the I, and you find a class that has that name and it implements the thing with the I, then make that connection. But like I said, there's cases where the conventions aren't going to work, and in this case, we're telling structure map to scan the assembly, and every time you find an instance of iShipping service, add that. So don't go out there and try to make one-to-one mapping between an iShipping service and some shipping service, because there's going to be more. So we're just saying, just keep track of all of them and know that they're all available for to fulfill a need for an iShipping service. Okay, so that's our configuration. Now, let's look at our controller real quick. We've got our home controller. And so without setting the dependency resolution, the IOC container, away from the default one, this would fail because activator.create instance does not know how to create an order processor, or doesn't know how to create a home control that takes an argument. So that fails. But now since we've replaced it with our own structure map dependency resolution, this will work because it will say, all right, hey, they need an I-order processor, so let's go ahead and go out and give them the order processor. And so if we, and by the way, the model here is the same thing that we had over our simple demo. It's just over here. So the same exact stuff, except now the injector has been replaced by a structure map. Let's go ahead and set a breakpoint right there. Again, to prove that I'm not blowing smoke here. So as we launch the application, there we go. All right, so our home controller is being created. We have our order process here, which has been resolved by structure map, and our order processor has a collection of shippers, which is both our UPS shipping service and our FedEx shipping service. Okay, now the thing where this gets kind of cool, and I'm going to try to do this real quick here. And let's say we have a interface like iFood. Doesn't matter what's in it. Doesn't have to be anything. We have a public class. Food that implements iFood. All right. So let's say that we've been using this. This is maybe our authentication module. This is what we use to do all of our authentication with. And suddenly, the boss comes in and says, "Hey, we need to authenticate calls to the order processor in the home controller." Because that sounds like a plausible thing. With the scanning, the convention scanning, things like that, it's really easy to just say, okay, now I need an iFood here because we got to authenticate. I don't have to go out anywhere else and say, okay, when it's time to make the home controller, we have to go update the home controller factory to include the food dependency. I just have to put that in there. I could even do like, I could put any other class in there that the resolver has a chance to create for me. So I'm just going to add the extra parameter to the home controller and run that again. And now when we hit this breakpoint, if we hit this breakpoint, still get our order processor, and now we have an instance of type food because the scanner has picked that up, has applied the convention, made the wiring for us, and yeah, I mean it's really easy to add different modules in different parts of your application as needed. Okay, so let's go back to here real quick and just finish it up. Yes. Okay, so to sum this all up real quickly, dependency inversion is a principle that helps reduce complexity or dependency calculating in your classes. Inversion of control is the pattern that helps us or describes abstractly how we comply with the dependency inversion principle. There are three ways of inverting control in your system, which is the interface inversion, the flow inversion, and the creation inversion, which is what we dug into the most here. Creation inversion comes in three flavors. We can do it through factory methods, service locators, or dependency injection, which is the one that we dove into most. Dependency injection is just one implementation of the inversion of control pattern. And there are three ways to inject dependencies. The constructor injection, which is the most powerful, I think, center injection, and the interface injection, which I wasn't able to show, I think, said I was going to try to. Okay, so in the end, it's one of those things where it seems scary on the surface because there's so much information, and It's not a natural way to think. This wasn't for me for a long time. And even when I watched courses, read books and articles, and went to talks about it, I didn't walk away thinking, okay, I could sit down tomorrow and, and completely redo my application with inversion control and make it testable and all that stuff. But as I kept on, identifying problems that inversion control solved, and then applying inversion control to solve those problems, after a while I just realized I was doing it without even thinking. It's one of those things you just keep your hands dirty, and before you know it, it's just a part of your toolbox. So very quickly, pros. Logic code to be loosely coupled, highly cohesive, which is, again, related to that single responsibility principle, solid principles, things like that. It allows it to be testable even though we weren't doing any testing. And even if you aren't doing any unit testing, writing your code in a testable way tends to make it more maintainable. And that's pretty ultimate thing. This is what you're striving for, so you don't have guys who have deep personal hatreds of you because they had to look at your code after you left. And it might reduce complexity. If you have a really large system, it's going to help you reduce some complexity because of that whole IFU and food thing there. If we have a whole bunch of things and I just started saying I need this, and this for this module to work, that reduces complexity. And I can just say, and my constructor, kind of as a declarative way, this is the things I need for my class to do its job, and IOC will do the rest for you. But in simple applications, it's actually going to add more complexity. So it's it depends. That's what the architect says, right? Should I use IOC? It depends. Another con is that it's not obvious to the uninitiated. Now we're all initiated now. We don't know all about IOC, but for the person who just shows up one day and has never heard of an inversion control container, they're going to look at your code and say, how in the hell did you get your list of shippers? I don't see that anywhere in your code. I searched the entire thing for the string new UPS shipping service, and there was nothing. How are you creating that? It's kind of black magic if you don't know what's going on, and that can be a con for maintainability. But the benefits here outweigh the negatives, so it's better just to train your team to know how to use it and not be afraid when they see that happening. And it's easy to overuse. You don't have to use it for everything. So there's the quote there from the architect. It depends. My general rule of thumb. Well, all right. So if you're writing an interface it's only going to be implemented once in your entire application, you don't need to create that abstraction. It's not necessary. You're abstracting it for no reason at that point. But as soon as you have, say, 2 implementations of it, which might be your order processor and your fake order processor for unit testing purposes, now you have 2 implementers of that interface, and now you should really be looking at IOC. The rule of thumb is, for me, when you have a pattern or a principle, don't apply it unless you're encountering some pain that it will help you relieve. But then have a low tolerance for pain. Okay? Don't use it if you don't need it, but as soon as you need it, do it right, and you're going to be happy in the long run. All right, so I'm over time, but I will hang around, and if you do have questions after we presumably draw prizes or do something,
Yep.
I will be around, and feel free to ask some questions.
All right, thanks.
Maybe.
So while we're doing that, I'll vouch for everything that Adam said. I have a similar background. I didn't know what it was, didn't use it right. Learned my lessons, and I feel like the
800 miles long, and there's no reason.
Learn that this stuff is really valuable, so. Yeah.
Of course, if I was running some snooping software on a Mac, you'd never know it.
I hate Macs and Mac saying these.
I was with you. I need to continue that conversation.
Oh, you don't have Silverlight. What? Oh, there's an update. Okay, remind me later, I'm sure you'll see it.
It's like, we just did our Lincoln drawing not too long ago. We're just whoa.
All right, so I'm gonna get it.
Oh, boy.
Oh, look at that.
You need that update.
Yeah, the butter going there. We got some t-shirts from Team here. Let's see. That's pretty nice.
You know, when I first got the Mac, I installed Windows and there fixed it. And
That's still good. Oh, boy, guys. Got the two $25 gift cards, a $50 gift card, and a $100 gift card for me. That's great.
And courtesy of Microsoft, we got some mugs and an Arc mouse.
Yeah.
is that from
What kind of
the programs?
Yeah, the spam program.
I don't know what to talk
Next
about
question is
that.
spam here. Yeah. So these are your clicks, basically. In here, I got more, so we'll get that away in the coming months. So let's do the t-shirts first. Actually, t-shirt to the mug, whichever you prefer. Oh.
Now the keylogger is running, so.
Oh, that's what it was.
Well, that didn't work on that?
Yes, it worked last week on Mac at least. See,
Is it
it's
on my own Mac or?
you're on the Windows side, so do it for Windows. See, it's Silverlight. Silverlight's dead. I mean, honestly, this is why it's not working.
Who has done Silverlight?
We're hiring for Silverlight too.
Silverlight is awesome.
It's phenomenal.
It actually is. I'm not just saying that. I can't believe I don't have Silverlight on there.
I can't believe it either.
We are switching probably to HR5.
Yeah.
Sorry, guys.
It's my fault. It's a Mac.
Is this laptop going to log me in? This isn't hard.
I'm kind of admit though. I mean,
I love it. Thanks for showing us.
I know, yes. But I cannot run Silverlight for about 16 hours
Hey, right.
between charges.
Got the password.
Oh, yeah.
It's so weird not having to, like,
Sorry.
there's been times when I forgot that my power cord at home. I've gone, oh crap, I forgot my power cord. No, I had this thing, so I was able to work an entire day at a coffee shop without having to plug it in.
I'm a liar.
That is pretty cool.
All right, you're going to see how long my password is. There you go.
So very early on, we had we were having a hard time finding speakers, so one of our sponsors provided a speaker for us. It was talking on Web 3.0, and I didn't know that we even moved on to Web 3.0. This guy came up and he set his MacBook on the podium to start his talk, and we were all kind of like, And then he said, to our .NET users group, all right, so we're gonna build a PHP app.
Oh,
And it was a disaster. And if you're here, geez, I don't know if I have this like. Has anyone here spoken to the Lincoln.NET users group?
I have.
Okay, well, it wasn't you, I know that. But, you know, most of us walked away and said, okay, that's why we're done it.
Yeah. You know, we should do that. Talk about PHP. All right, so first winner, you get to pick a t-shirt or a mug, goes to, do this quick.
Takes you out 150 now.
Look, I'm telling you, this Silverlight worked yesterday. He did this on.
I have a feeling we're gonna go through a few of these, because we had 50 people RSVP and about 25 showed up, so Dennis isn't here. You see these people, tell them. Cool. Couple. Right. Kate?
Right here.
Yeah? What do you want?
I don't even know.
All right. So that's. No? If you guys haven't seen Lincoln's, look at Glenn.
One shirt, right?
Oh, yeah, one.
You must really like the shirt.
Joe. There you go. What do you want?
I'm still wearing it.
I'm
I'm still wearing it.
All right, yeah.
No, Dan.
No, Dave.
No team people.
Yeah.
Mike, right here. All right, so we got some. You know, I will let you guys, we'll save the $100 gift card. Actually, we'll do the $25 gift cards with a mouse, that's right about equivalent. Hunter.
You know what, I'm probably not the ideal person to get this, but I was just going to put in a shameless plug for Irish Consulting. So if anybody's looking for a new job or interested to see what's out there, give us a call.
Did you get the?
No, we'll just put it back in the pot to resell it. Or to
Okay.
re-gift it, I guess, just to see it.
Great. Todd. Dan went too. I want you to show up. Bean's not here.
Team employees are exempt.
Brian. Brian's not here. No?
No team people.
Josh. There you go. Which one do you want? Mouse? All right. Karen.
She's down here.
Mark. So we have a lot of people who the interest in didn't convert. Joel, did any of you RSVP?
I mean, see, my name fly by.
All right. Ryan. We are right.
What's left?
Actually, we don't get to choose. $25 gift card. Other Ryan. Mark. Oh, there you go. I tried.
Well, see, that's how you do it. You just throw it out there.
That's enough. I'll get some excitement. All right, for a $50 gift card, Tim. So Tim, you missed out on $50. Travis.
No team people.
Well, that's like half the people then.
Stan.
So talked to him last night, but he didn't show up tonight. Okay.
Yeah, tell Stan.
He told me about tonight.
Tell him
Here's
it's
$50.
Okay.
$50.
Todd. Five hard, I'm taking it hard. Nice. All right, and for $100 Visa gift card to your favorite store. Gene.
Oh,
Yeah?
she won the grand prize last time.
All right, that's all I have. I want to take this time to thank Adam for driving up. The team for their support for the user group. I'm sure you talked to them. Good job. Thank you.
Yeah, have a good night, guys. Yeah, I think that's part of it. Yeah. I've never used it. I've heard of it. Things like this, but yeah. Did you read it? I did it on my phone. The second time. Logged in and so I didn't work on my phone. Yeah, I didn't feel on the Mac. Like, alright, I put my name on it because I didn't do it. I want to do my 360. Did it? No, they have a really